Hello Chemistry. Today's lab is called Meltdown Madness. This is an open-ended lab where the student is going to design and conduct the experiment, one that hopefully is going to collect meaningful data. So what do we want to try to find out today? Well, here in Aspen, we often have issues with icy roads during the snowy winter. So sometimes we use ice melt on the roads. There are different kinds of ice melt. So you are going to be given 3 different types. This is sodium chloride, magnesium chloride, and calcium chloride. All will melt ice, but in Meltdown Madness, we want to know which one does the best job of de-icing. So, how do you design an experiment? Well, you're going to need amounts of each of these, and one of the criteria that we're going to state for this lab is that you want to use up to 20 grams of each substance, but no more than 20 grams. So we want to work with small amounts here so that we make efficient use of our resources. You're probably going to need a scale, and let's go ahead and put this down here. So you're going to want to, now it doesn't have to be 20 grams. It could be 10 grams, it could be 5 grams, but you probably want to be consistent in using the same amount of each ice melt. Why? Because when we design an experiment, we want to control as many variables as possible such that if we were to repeat the experiment, we should hypothetically get the same data. Okay? Now, if we're going to melt ice, we're going to need some ice. So ice will be provided for you. And really, it's up to you how you want to design and conduct this experiment. All the materials are available in lab, so you can get beakers, whatever you want. But for an example, what if you were to try to melt the ice cubes in this beaker with sodium chloride and in this beaker with calcium chloride? Can you see any potential issues with this? Are the beakers the same? They're not. They're different size, and they have a different surface area on the bottom. So that's an extra variable that might impact our outcome. So a better way to do this would be to control the variables and use beakers of the same size. Let's also take a look at the ice. Now, good. Okay, so let's say that you wanted to do 2 ice cubes in each one. Do you know for sure that these ice cubes are the exact same size? Is there a way to determine and maybe even it out so that you have the same amount of salt acting upon the same amount of ice so that you can really get a feel for which one of these is the best de-icer? And finally, what you want to think about before you conduct your experiment is how are you going to measure your results? So if you're trying to melt ice, what's the best way to determine the best way to melt it? It needs to be quantitative. You need to measure something in numerical. You don't want to do something qualitative, which would say, for example, oh, this one looks like it has more melted water in it than this one, per se. Somehow come up with a way to measure your results. Record them in a data table, put the appropriate units and a title. Those are your instructions. Good luck.